Now we are going to learn about vector product or cross product of two vectors in this section. Now we have already learned about something called scalar product or dot product of two vectors. And let's recall very briefly what we said earlier. We said that if there are two vectors, suppose we call them the vectors P and Q, and they are inclined at an angle of phi between them, the dot product or scalar product of these vectors was defined to be, the symbol was this P dot Q. This is given by the magnitude of P into magnitude of Q into cosine of the angle between the two vectors. This angle should be taken to be the smaller angle, but even if you take this larger angle, it makes no difference because cosine function is an even function. Cos phi and cos 360 minus phi has the same value of cos phi only. Now this is a dot product or scalar product, which means that the product itself is a scalar quantity, although it's the product of two vectors. Example was, of course, I said that was work. Now when I mention the term vector product, then definitely it says it implies something different. So let's see what it means. I just say give a formal definition in a short time, but let's see what we can interpret from the name of itself. This P and Q, there are two vectors, and suppose there is an angle between them phi. But this time when I say vector product, we write notation something like this: P vector cross. We don't give a dot symbol, we give a cross symbol and then write like this. And I write this and read this as P cross Q. I read this one earlier as P dot Q. This was read as P dot Q scalar product, but this I read as P cross Q. That's why the vector product is also called a cross product of two vectors, which happens to be itself a vector. That is interesting. The previous case we found that it was a scalar thing coming out to be PQ cos phi, but P cross Q itself is a vector quantity whose magnitude, I'll be showing all these things in detail. The first thing to note here is that the two distinction. First, in the notation in dot product, we use a dot between the two multiplying vectors. In vector product, we give a cross symbol. So that's why it could be called vector product or cross product. And as the name suggests, the dot product is a scalar quantity, while vector product or cross product is a vector quantity itself. So that's a big distinction. And let us now say what vector product is. The vector product of two vectors is a vector quantity whose magnitude is equal to the product of their individual magnitudes and the sine of the smaller angle between them. We shall see everything by figure, but I read the sentence and I think you have followed it. The direction of the vector product is perpendicular to the plane containing the given vectors, and its sense is determined by the right-hand corkscrew rule to be discussed. We shall discuss separately, but the definitions given here will help us to understand and construct what is meant by a vector product. Let us at the beginning consider a plane. I have to visualize a plane. This is the plane of the desk on which your laptop is placed. This is a simple tabletop. This is horizontal. Okay. Now suppose I just consider two vectors. One of them is this. This is placed in the plane of this white tabletop or this horizontal plane. This white outline is of a horizontal plane, and on this lying on that plane is this vector, and another vector. Let me just also draw it matching their tails, and this is like that. So I might call them as usual by notation. So the common tail, let me call that as O, and one vector is given by the arrow OA. Let me call the vector as vector P. The other vector is I'll be calling OB, this arrow representing a vector Q. Now you can see that both the vectors P and Q given by OA and OB are lying on this horizontal plane as defined by this white outline, right? Now the question is, the first of all they said that when I go for P dot Q, refer to this figure and try to understand P cross Q. When I say that, this is given by the magnitude of P into magnitude of Q into sine. This is the smaller angle between P and Q vectors. So let me call this angle as phi. Here it's important to say smaller angle. In case of dot product, I didn't even mention the angle. Whether you take this angle or the larger angle, it does not make any difference because I said cos function is an even function. That here we must specifically say that P cross Q is given by PQ into sine of the smaller angle between these two vectors. You can always measure an angle between two vectors, first letting their tails match. And when you make their tails match, you can measure the angle, and the angle could have been either this, it could be either this, or it could be the larger angle like this, but you don't take the larger angle because sine 360 minus theta is minus sine theta, and you don't take that. You go for the smaller angle between the two vectors and take this one and write accordingly that P cross Q, this is the magnitude part. Let me be careful. I must say this is the P cross Q, the modulus value of that, the magnitude of this vector. That is, if I said that P cross Q is indeed given by a vector that is S vector, this is actually standing for the magnitude S, right? Now this is my question number 1, and I can see the figure once again and try to understand once again as a repeat of what I said. The P cross Q is defined to be a vector S whose magnitude S is given by the modulus value of P cross Q, that's given by the magnitude of vector P, that is the length OA here, magnitude of vector Q, that is the length OB here, multiplied by sine of the smaller angle between the P and Q vectors. You don't take the larger angle because sine function is an odd function. Sine 360 minus theta is minus sine theta, so just avoid that. That is the magnitude part of the cross product of two vectors P and Q. Second part is of course a little more bothering. So I'm once again saying that the direction of the vector product is perpendicular to the plane containing the given vectors, and its sense is determined by the right hand corkscrew rule, which we'll discuss separately. So this is a big point here I have already mentioned in the introduction of vectors.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.